Hello, so I am Vedant and let's get started with today's discussion. Today we will be discussing Codeforces Round 1082 Div 2. So let's start with the first question. Uh, Yeah, that's great, Jatin. The first question is parkour design. Today Alex wants to build a parkour course for Steve to train for his parkour skills. A parkour course is a sequence P0, P1 up to Pk of integer coordinates on the plane. Here, a continuous pair of coordinates is called a move, denoted as pi minus 1 to pi. Alex knows that Steve can only perform the following types of moves. That is, there are three kinds of moves. Either x will increase by 2 and y will increase by 1, or x will increase by 3, or x will increase by 4 and y will decrease by 1. Note that Steve will not perform any other type of moves. For example, 0, 0 to 2, 1 is valid, 2, 1 to 5, 1 is also valid. Because 0, 0 to 2, 1 is operation 1, 2, 1 to 5, 1 is operation 2. But we'll never perform moves such as 2, 1 to 3, 2, or 3, 0 to 5, minus 1, or 4, minus 1 to 6, minus 1. You are given an integer coordinate x, comma y on the plane. Please determine if it is possible to make a parkour course from x0 to xk, satisfying that our initial coordinate is 0, comma 0, and we have to reach x, comma y. The parkour course only consists of moves that Steve can perform. And our number of test cases are up to 1e3. Our x and y are from x is up to 1e9 and y is from minus 1e8 to plus 1e8. And we just have to tell whether it is possible or not. So, so basically, we are given three types of operations. We can say operation one is, suppose our initial coordinate is x comma y, right? So our operation one will change it to x plus 2 comma y plus 1. Our operation 2 is x plus 3 and y, and our operation 3 is x plus 4 and y minus 1. And our initial coordinate are 0 comma 0, and we need to do some steps so that finally we reach a coordinate of x comma y, right? This is our problem. So if we notice this in a single operation, we can increase the value of y by either plus 1 or minus 1 and keep it same, right? So basically, let's say from 0 comma 0, I need to reach a point, let's say x dash comma y, right? So how will I reach it? First of all, let's say I do operation 1 and operation 3. What will happen? Operation 1 plus operation 3, right? Let's say my initial coordinates are x1 comma y1 instead of x comma y, because variables will be different that way. So if I do both operation 1 and operation 3, my coordinates will change from x1 comma y1 to, first of all, x1 plus 2 comma y1 plus 1, and then to x1 plus 6 comma y1 plus 1 minus 1, that is y1 only. And what if I do operation 2 twice? Right. x1 comma y1 to x1 plus 3 comma y1 to x1 plus 6 comma y1. So what we can notice is operation 1 plus operation 3 is pretty much equal to operation 2 plus operation 2, right? And what we know is that when we do operation 2, only our x coordinate change, y coordinate does not change, right? So let's say I need to go from 0 comma 0 to x comma y, right? So what I can say is, let's say my y is positive, or first of all, let's say my y is 0, right? Let's say y is 0, right? So all I have to do is change my x coordinate from 0 to x, right? So I can only do operation 2. That is, I need to go from 0 comma 0 to x comma 0. And if I do operation 2 k times, right? So what will happen? My coordinate will change to 3k comma 0, right? So basically, if x is a multiple of 3k, or I can say easily that if my x modulo 3 is 0, then it is yes, else it is no, right? Now, suppose my y is positive. So what I can do is I can go from 0 comma 0 to some x dash comma y, and then from x dash comma y to x comma y, right? Hi. For a diff to A, what topics should I need to learn? See, the first problem is basically maths only, so you only need to work on your like logical skills and all. Just solve multiple questions and then slowly you will be able to solve it. There aren't really topics you can study for this. Maths plus SS. Where are you life at this time? Actually, I had to go out yesterday, so I couldn't take the PCT that time. I wasn't able to solve B. Yeah, we'll discuss B. Yes, so basically, first of all, what I can do is I can make my y coordinate correct. So for making my y coordinate correct, I need to do operation 1 y times, right? Because it for each operation 1 my y will increase by 1, and then I will do operation 2. So let's say I do operation 1 y times, right? So it will change my coordinate from 0 comma 0 to what? My y coordinate will be y and my x coordinate will be 2y. And then I need to go from 2y comma y to x comma y. And this is again basically only operation 2 k times, right? And what will it make my x coordinate? My 2y will become 2y plus 3k. So basically x minus 2y modulo 3 we need to check, right? And again, if this is 0, then it is possible. If it is not 0, then it is not possible. And now if my y is negative, right? In this case, again, what I can do is for my y negative, I can do operation 3 first to make y value match, and then I will do again operation 2. So what I need is I need to change my x comma y to some x1 comma, okay, my 0 comma 0, right? 0 comma 0 to x1 comma y, and then that to x comma y, right? And we know this is negative, right? So we do operation 3 y times, right? So my coordinates will change from 0 comma 0 to 4y comma y, right? And then I will do operation 2k times. So my coordinates will become 4y plus 3k comma y. So basically what I can say is that again x minus 4y should be divisible by 3, right? X minus 4y modulo 3. We need to check this. So basically for the three cases, all we need to check is whether x modulo 3 is 0 or not, or x minus 2y is 3 divisible by 3 or not, or if y is negative then this, right? And this will basically solve our problem. In fact, in the first case, what we can see is this is nothing but an extension for the second case only, right? Like suppose in this, if we put y equal to 0, then it becomes x modulo 3 only, right? So basically we need to check only these two conditions, right? So let's test the examples. For B type problem, what topic should I learn? We'll check B after this, then we'll discuss the topics. So in the first problem, we are given 2 comma 1. So when we do our one operation, like basically what we need to check? We need to check if x minus 2y is divisible by 3 or not. So 2 minus 2 is 0, so it is true. In the third case, we have 3 comma 0. So again, 3 minus 0 is 3, that is divisible by 3. In the fourth case, we have 4 and minus 1. So this is our second case, right? X minus 4y should be divisible by 3 or not, right? So we do 4 minus 4, that is 0. So 0 is again divisible. For the third case, we do 4 minus 2, that is 2. 2 is not divisible, so it is false. For the fifth case, it is 14 and 1. So we do 14 minus 2, that is 12. 12 is divisible by 3, so it is true. And similarly, we'll see that all of these will come out to be true. And one more thing we need to notice is that here x minus 2y should be positive, right? And here also x minus 4y needs to be positive because we can never decrease the value of x, right? I was so close to solving it but gave up early. I just had to check if remaining is less than x. Yeah, it's fine. Like, don't give up next time you. It is possible that you are very close to the solution, right? Just keep trying as long as the contest is going on, at least. So let's check the code now. So if y is greater than 0, then what we are basically doing is we are subtracting 2y from x. And if y is less than 0, then we are adding 4y because now y is negative. And then we are checking if x is less than 0, then it is false, or if x divided by 3 leaves a remainder, right? X modulo 3 is not 0. So if either of these two cases happen, then our answer is no, else our answer is yes. So this was problem A. So let's move on to the second question now. AB construction. There is a string T of length n such that Ti is A for all odd I and Ti is B for all even I. One day Bob generated a string S with the following algorithm. Okay, so first of all, let's start the string T. So our string T is like A, B, A, B, A, B, A, B, and so on, right? If let's say n is the length, like so we can see if n is even, then like count of A is nothing but n by 2, and count of B is also n by 2, right? And if n is odd, so what we can notice is that count of A is n plus 1 by 2 and B is n by 2 here also, right? Let's say for even we take n equals to 4, then we get A, B, A, B, right? And for odd case we get, and for n equals to 5, A, B, A, B, A, right? And we can also notice that in this case, we have both the access for A and access for B. But here we only have access for A, right? So let's check the question further. One day Bob generated a string S with the following algorithm. Initialize S to an empty string, remove either the first letter or the last letter from T and append it to S. If T is empty, terminate and return the string S, otherwise go back to step 2. Yeah, so we discussed the algorithm as well, kind of. Like suppose our string is of even length initially. So we have access to both A and B, right? So if n is even, like, right, for this case, our first character can either be A or B, right? But for an odd case, our first character is definitely A only, right? So this is, we can say, our first observation. Then Bob write down the string the generated string S on a note and forgot about it for a few years. The note was worn out when Bob found it, and someone might have secretly changed some letters. Of course, Bob wants to know if someone did alter the string. You are given a string x of length n consisting of a, b, and question mark. Please determine if there exists a string a which satisfies the following condition. That is, length of a is also n. ai is either a or b for all i's. ai is equal to xi for all values of x if it is not a question mark. And string a can be generated from this algorithm, right? So basically, we are given a string x and we need to replace the question mark, right? Replace the question mark with either A or B to get the string A and tell if string A is possible or not, right? This is basically a problem. One thing we have already noted down. Let's write it again. If n is odd, right? So let's say our string, let's say the string we are considering is S only because we are using A and B for the count of A and B, right? then our S0 must be equal to A, right? This is our first condition. If this is not true, then definitely it is false, right? I used DP, it was not required, but I did 3D DP, TPI, PLPR, PL and PR are the parity of L and R. Yeah, that is kind of an overkill. You don't need DP for this problem, but it is still good. So suppose, let's say as n was odd. After making the first character A, what we can say is, like, let's just take an example, right? Let's say our string is A, B, A, B, A, B, A, right? Here our n is 7, right? So first of all, our first character must be A, right? Let's also check the constraints. So our constraint is that n must not exceed 2e5. And definitely all characters for the string x is either a, b, or question mark. And we need to tell whether it, it is possible or not. That is yes or no. Right. So O of n or something similar will work. Right. O of n or O of n log n square won't work. So let's get back to the problem. So now we can select either the first character or the last character, right? So since both of them are 8, doesn't really matter which character I choose. So let's say I chose the last character. Let's remove this. So basically what we can see this, doesn't it just change the question to n equals to 6, right? And now we have the string as AB, AB, AB. And now our, like in this case, our next character can either be A or B, right? Let's say if our next character is B, right? Let's say we have this string A, B, A, B, A, B, and we choose B, right? So our next character is B. So again, our next character must be A only, right? If we choose a B, this character is definitely A, right? And let's say if we had chosen A, let's say we chose this, right? So what we can notice is that in this case, our next character is definitely B because all we have available is B on both the ends, right? So this was our first observation. If n is odd, then our first character must be A. What we can say for a second observation? Actually, let's go a bit further. Like after we have chosen B, we can remove this A also because we definitely need to choose A, and for this, let's remove our B. Right. So what is our third character? Now again, a third character can be anything. Right. A or B. Here also our third character can be anything. A or B. Right. So let's consider the first case. A, B, A, B, A, B. Right. We have chosen a B, then we have chosen a A. Right. These two strings are done. Now we can either choose the next character as B or next character as A, right? But for this, what is our left string when we have chosen a B? Our string is A, B, A. And for this case, our string is B, A, B, right? So again, we already know what the next character should be, right? And in the opposite case, when our first character was not B but instead A, right? When we have chosen this as our first character, and let's say we have chosen these two characters. Right. That is A and B. Then again, our next character can be anything A or B. Let's say we have chosen A here and B here. Then again, we already know what our next character should be, right? Because in the first case, we are left with B, A, B. And in the second case, we are left with A, B, A. So can you notice that at times we don't have an option, but at different times we have an option of what characters we can choose, right? So, for example, when we have chosen for example, when our n was 7, we didn't have a choice. But for n 6, we had a choice. Again, when our n was 5, we didn't have a choice here. And then again, didn't have a choice when our n was 3. So basically, what I can say is when n is odd, we don't have a choice, right? And when n is even, we can choose either of them, right? Right. This is basically a second observation we can say. And what we can also notice is that in the first observation, what we said was if n is odd, our first character is A. But this is also equivalent to we don't have a choice, right? Now, what we need to know is when n is odd, when is it A and when is it B, right? We know that we will definitely know whether it is A or B, but we just don't know which of them will it be for each possible case, right? So again, let's look at the string. Actually, what we know is that here both are starting and the end string was A, that's why we had to choose A. Similarly, in this case, our start first and last string were A, that's why we were choosing A, and here our first and last string was B, right? So what we can say is like why no choice, right? Because for odd n, our first character is equal to our last character, right? And also, what we can say is, let's say again, A is count of A and B is count of B, right? What we can say is that since our n is odd, either A will be greater than B or B will be greater than A, right? One of them will happen. So definitely what we can say is if A is greater than B, choose A, else choose B, right? Can we say can we say this is our sub problem? My rating is 300. How to improve rating? I just started CP. See, just keep solving questions, keep giving contest, and slowly your rating will increase definitely. You can try the CP31 sheet that's on the TLE Eliminator website. It has good questions. Right, so what should be our operations, right? Let's say we take out, we find A and B first, right? As respective count of A and B, right? Now what we know is that if A is not equal to B, right? In this case, either A is greater than B or A is less than B, right? In this case, choose A, and in the other case, choose B. And what will this choice do? This will change A to A minus 1, and this will change B to B minus 1, right? Also, we already know that in the odd case, like we calculated the number for our initial string, that was n plus 1 by 2 or n by 2. So the difference between A and B cannot be more than 1 as well, right? Because the string is nothing but alternate characters of A and B only, right? So after we have done this operation, our string will definitely become equal, right? So our else case is A is equal to B only, right? In this case, we can choose anything, right? And now in the question, we are already given a string, right? So let's say we have the value of A and B are not equal. Then we already know whether we need to choose A and B, A or B, right? So if what we need to choose and what the given string character is, if they are not equal, then it is not possible, else it is possible. And in case A and B are equal, so we already know that we can choose anything, right? So whatever is the given character, that is the correct character, right? So let's extend this further to include X, right? We know how the strings are created. We are given X. We need to tell if it is possible or not. Right. So again, what we can say is that if A is not equal to B, right? In this case, let's say if A is greater than B. So we need to choose A, right? So let's say our character of X was our character Xi is B. So in this case, our answer is definitely no. If Xi is A or question mark, right? In this, this specific character is valid, right? And similarly, the case for if A is less. then B. So we need to choose B, right? So in this case, if xi is A, then it is not possible. Else, if xi is either B or question mark, then it is valid, right? And in the first case, what we do is we decrease A by -1, and here we decrease B by -1, right? And then our case, in this case, we already know that, right? A and B are equal, right? So what we can say is that if our xi is A, then decrease A by 1. If xi is B, decrease B by 1. And if xi is question mark, then we can choose it. It can be anything, right? So can't we say this depends on the next character? Right. That is if xi plus 1 is A, then our in this case our xi will be B, right? Because then our B will decrease and A will be more. And in case our xi plus 1 is B, then our xi will be A, right? So this is kind of a safe case, right? And a string can become invalid only when A and B are not equal, right? Because our no condition comes here only, right? And if all characters are valid, then our answer is yes. Can we say this is basically our question? Suppose let's solve the first case. Here A is already in the correct form, right? Let's see the second case. B. B. We know that a string is of 5 length, so initially our A will be 3 and B will be 2. So according to this, our first character needs to be A, right? And that is not the case. So it is not possible, right? Let's check the third string. Question mark B, question mark A, B. So again, this is length 5, so A is B and B is 2. So our x0 is A, and now A becomes 2. So our x1 can be anything. So now our x1 is given as B, right? So what this will do is this will decrease B by 1. Then our x2 can be anything. So x2 needs to be A again, right? So our A will decrease by 1. Now our x3 can be any character. It is given as A. So our A will become 0. And now again B is more. So our x4 needs to be B only. And it is B, so B will become 0 as well. So this is valid, right? And let's check the last case now. Double A question mark B question mark B. Right. So here our A is initially 3 and B is also 3. So our first character can be anything and it is given as A. So our A will become 2. And now second character needs to be B. But that is not the case. So it is not possible, right? So we can check all the characters in this form, right? So let's check the code now. So we have taken the string as input and we have calculated the initial values of A and B. We have also taken a variable q. We will discuss this later. So let's say our A is greater than B. So if our character is B, it is not possible, else decrease A. If our A is less than B and our character is A, then it is not possible, else decrease B by 1. Right. Now our length is equal, so we can choose any one, right? We can choose A as well as we can choose B. So if our character is A, decrease A, else decrease B. Else what we can do is we can decrease any of them, right? So in this case, it depends on actually on the next character, right? So what I've done is if my initial value is question mark, so I'm increasing the value of q. Now what is it does is it gives me the freedom of choosing the second character as well, right? Because since I'm not decreasing A and B, so my second character can be anything, right? That's what I'm saying. So let's say my second character is also a question mark only. So in this case, what I'm saying is since I've already taken a question mark, in this case, both my A and B will decrease by 1 and I'm changing the value of Q again to 0. And if my this character was A, then my previous character must be B, so I'm decreasing B and reducing Q to 0. Else I'm decreasing A and reducing Q to 0 again. This is basically what we discussed here, right? If our next character is A, then our current character needs to be B. If our next character is B, and our current character needs to be A. And the third case is if our next character is also a question mark, right? And we know our current character is also a question mark, right? So in this case, both A and B will decrease by 1, right? Because we can set one of them to N and one of them to V, and it doesn't matter which of them we set to what. So this basically solves the problem. So actually, there is one more method to solve this problem in case you have noticed a pattern. What we know is that, right, this way is actually easier to code. What we know is that if n is odd, like initially, right? So our x0 needs to be A, right? And now after this, what we can say is then the problem is decreased to n as even only, right? So let's generalize for n is even, right? Because in this case, we are changing n to n minus 1 only, and we are as if we are selecting the last character, right? So now let's consider that n is even, right? So let's say if my S0 is A, so what exactly is happening? My initially my A and B were equal, right? A was equal to B. So in this case, I'm decreasing A, right? So what will be my S1? Now here, since A is less than B, so S1 is definitely B, right? And in case, and after S1 is B, now again, what I'm doing is I'm decreasing value of B. So again, after this, my A is again equal to B only, right? And what we have chosen is we have chosen AB. So what should, let's say this time we choose the first character as B, right? So our B will decrease. And then for the next character, our A is greater than B. So this time we need to choose S1 as A, right? So our A will decrease. And again, after two characters, our A is equal to B, right? And this time we have chosen a character as B. So what we can see is that, like, let's say, like for any one, let's say these are our characters, right? So if we take two characters at a time, so each pair is either AB or BA. If not, answer is no, right? So this is another way to solve this problem. And you can definitely check that this method is easier, right, to code as well. And this is for odd, for even in. If n is odd, right, first character is A, and then solve for n minus 1. And this is again even, right? So these are the two strategies we discussed for the second question. So let's move on to the third question now. So C1 lost civilization, and this is the easy version. In this version, we need to compute a value for one sequence. And let us define an algorithm to generate a sequence of m plus k integers. First, receiving a sequence of x of m integers as input. If k is 0, terminate immediately and return the sequence. Then select an index I and insert xi plus 1 immediately after the xi element. If x contains m integers, return the sequence. Otherwise, return the second step. Return to the second step. Alice knows that the algorithm was used by an ancient civilization in order to hide their secret safely. Alice wants to learn the knowledge that they wanted to hide, but it is not an easy job to infer the input from the output of the algorithm. Given a sequence A of n integers, determine the length of the shortest sequence that could be given as input for the algorithm to generate A. So let's see what all we can generate from an integer, like from one number, right? So let's say my sequence is A1, A2, A3 and AK, right? Or should I say AM, right? Or let's not use A as A is our input. Let's say my sequence is X, that is X1, X2, up to some XK, sorry, up to XM, right? And then I'm generating K numbers, right? And that then we get A as A1, A2, up to AK plus M, right? And these are our n integers, right? So let's say we choose XK, right? So what all can we generate after this, right? We can generate, in fact, let's say that we have chosen XK and its value is, let's say Y, right? So this is our number XK and its value is Y. So first of all, the next number can be Y plus 1. And if then we choose this number, then our next number will be Y plus 2. And again, Y plus 3, Y plus 4, and so on we can generate, right? Let's say we choose Y again. So we will get another value here as Y plus 1. And we can get another value here as Y plus 2, Y plus 3, and so on, right? And here also we can choose Y plus 2 again, right? So here we can get another sequence as Y plus 3, Y plus 4, and so on, right? So let's take an example. Let's say we are choosing 5, right? So when I choose the number 5, then what I'll get is my next number will be 6. If now I choose the next number 6, then I'll get 7. If I choose 7, I'll get 8. If I choose 8, I'll get 9, and so on, right? Now let's say now I again choose 5. So I can get this sequence again, let's say 5, 6, 7, and like I choose this 5 twice, right? And this now these sequence will come as it is here, 6, 7, 8, 9, and so on, right? Right. And let's say now I choose this 7. So what will happen? I'll get 5, 6, 7, 6, 7, 8, 9, 10, 11, right? From this 7. And then I'll again get back my 8 and 9, right? And my n is up to 3, 5. So again, I need to solve this in either O of n or O of n log n, right? I can't go up to O of n square again. So what I can notice is, let's say we had 5 initially, right? And what we were able to generate, 5, 6, 7, 6, 7, 8, 9, 10, 11, 8, 9, 10, right? Or we can generate 10 as well, but let's keep it up to 9 only. So, and we are asked to, like, Alice knows that this algorithm was used and Alice wants to learn the knowledge they wanted to hide. And we are given a sequence of n integer and we need to determine the shortest sequence that could be given as an input for the algorithm to generate A. So basically, let's say this is our A, right? And from this A, we need to find this shortest sequence, right? So the problem is how to find the sequence from A, right? We know that if we have a sequence, we can generate multiple sequence, and it is easy to generate, but converting the sequence back isn't that easy. Can we see some pattern here? Well, the first pattern we can see is that if the elements are in increasing order of difference one, let's say our elements are y, y plus 1, y plus 2, and so on. Right. In this case, it can be converted to a single element y only, right? So this way we can see that we can select the first element 5, 6, and 7. But what about this 6? Now what we know is that when we are selecting 5, 6, and 7, so this whole array is converted into 5 only, right? Or let's write this down again. 5, 6, 7, 6, 7, 8, 9, 10, and then 11, 8, 9, right? We are given this sequence and we need to shorten this sequence, right? And we have made one observation. So let's say we select the first three elements 5, 6, and 7. We already know that we can convert this to 5, right? So this shortens our sequence a bit, and now our sequence is 5, 6, 7, 8, 9, 10, 11, and 8, 9, right? Now we can again notice a increasing sequence of this form, right? And now again we can decrease this to 5, and we get 5, 8, 9, right? And now what we can notice here is that we can't decrease this further. We can't choose 5 again, right? So this time what we'll do is we'll choose 8 and 9. And now what we'll get? We'll get 5 and 8, right? So according to our this algorithm, our smallest length was is 2, right? But we already know that actually we generated this whole sequence from a single number, right? So definitely this is false. So this algorithm is not complete, right? What we can say is our observation is incomplete. Store it at set and clear set where condition fails, but failed at preset 4. Retest 4. Right, so we need to modify this condition a bit somehow. So what we know is that, let's say instead of reducing this whole sequence to 5, what if we reduce this to 5, 6, and 7? Right? Because we can do that as well, right? We can select 7 here and then reduce this whole expression, right? So what we'll get in this case? We'll get 8 and 9. And now if we select 5, then our sequence will be converted to 5, right? So this time our length is 1, and this is correct. But the thing is, how we'll know how many numbers we need to take while reducing, right? So let's say we propose another possible method. Do 1, but from the back. that is from I equals to n up to 1, right? So let's try this again. So now what we can say is that if we do this from the back, this will be reduced to 8. And then this whole sequence will reduce to 6. And then this sequence will become 5. And if we do this again, then this and 5 and 6 will again reduce to 5. And again we will get 5 and 8. So this also does not work. Right. And again, what we can notice is that instead, if we actually chose like this much sequence 8, 9, 10, 11, or let's say we chose this 7, 8, 9, 10, 11, and reduce this to 7, then it would have worked, right? And this 6 would have come here as it is, and this then it would have worked. But again, we can't just do this arbitrarily and decide what to do, right? So, how to solve this? Actually, let's get back to seeing how did we generate this sequence. We had a 5, and what we did was we increased the value of 5, right? We increased this value up to 9. So what we did was 5, 6, 7, 8, and 9. And then we chose this 5 again and made another sequence as 5, 6, 7, right? And then we chose this 7 and made another sequence here as 8, 9, 10, 11, right? This is what we did. But now initially what we had was we only had 5. That is, we could only generate numbers like 5 plus 1 and then 5 plus 2 and so on, right? And then we converted it to, right. And then what we said was now we can choose, right. And then like if we are choosing the number y, then we can get 5 plus 1, right? But the thing is that this is not very effective, right? And why this is not very effective? Because we don't really know how many numbers it will be reduced to. We need to find some good method, right? So if we again, let's say we again pick up this sequence and try to do something else. Our sequence is 5, 6, 7, 6, 7, 8, 9, 10, 11, and 8, 9. Let's try to see that for like what can be our possible next value if we know that we got this from our initial value 5, right? So what we are doing is we chose a value 5, and now we need to check whether we can generate the other values or not. Now since we have chosen 5, our next value can be 6 only, right? Our next value can only be 6, or we need to choose another number. Right. And our next value is 6. So we have chosen 5 and our next value is 6 only, right? So after we have chosen 6, like we have chosen 6, right? Now what can be our next value? Now our next value can be 7, but our next value can be 6 as well. Because again we can generate like now we our sequence is 5 and 6, right? After choosing the value 6. So we can either choose 5 now or we can choose 6. So our next value can be both 6 and 7, right? Like I'm not writing this because then it is difficult to see the sequence again and again. So let's say see, let me write this down again. Right. I have chosen 5, right? So now my next value can only be 6. So it is 6 only, then that's why I'm directly choosing it. Now my next value can be 6 or 7, because in case I would have chosen 5, then I would have gotten 6, and if I'm choosing 7, then I would have gotten 7, right? So I'm choosing 7, so it is valid. Now my next value can be anything from 6, 7, and 8, and it is 6, then again it is valid. Now since I've chosen the value 6, so what I basically know is that this value 6 would have come from 5, right? So now I could choose 5 again for the next value. So I could get 6, or I could choose this 6 to get 7. But now I cannot get 8 anymore, right? Because once I, because I would have definitely generated this 6 before I would have generated this 7, right? So now I can't get 6. Sorry, I can't get 8 now. So my next value is 7. And now again, my next value can either be 6, 7, or 8. And that is 8. Similarly, my next value now can be anything from 6 to 9. And now from 6 to 10. And so on now from 6 to 11, right? And now this value can be from 6 to 12. And 8 is valid. Now again, since I've chosen 8, so now I can choose 6, 7, 8, and 9. But again, now I can't choose 10. Why? Because I would have definitely chosen this sequence, like the sequence before 8, earlier than 8. And this sequence was allowing me to choose the values greater than 9, right? So now again, I can't choose 9. Sorry, I can choose up to 9 only. I can't choose 10, right? So now this must be from 6 to 9, and it is 9, so it is valid. So what we can basically see is that, let's say, like for each index, we can get range of possible values, right? Let's say we can get our value from L to R, right? Right, for ith index. So if xi is less than L or greater than R, or basically what I can say is not in range, right? Then we can't generate xi, need to choose it. Else our range is now L2 xi plus 1, right? And in case we need to choose it, then what is our range? Isn't our range nothing but xi plus 1 up to xi plus 1? Because initially we could only choose one element, right? So isn't this basically our condition? Right. Good example of monotonic stack. I was able to solve C1 pretty easily. It feels like a LC type problem, but couldn't solve A and B. We can use stack. Yes, we can use stack. We have actually the thing is C1 can also be solved without the implementation of stack, but for C2 we definitely require stack. So first of all, I'm telling this without stack implementation, and then I'll extend it to stack for C2. Right. So we are basically getting the ranges for each value, and this way we can calculate the number of elements, right? So now let's check our test cases, like whether this works or not. Yeah, we can use stack for this approach. For example, in the first test case, we are given 1, 2, 3, 4, and 5. So what we can notice is that all these elements are in the increasing order only. So we'll definitely get 1. In the second case, and the difference is 1 for each element, right? For the second case, our elements are 1, 3, 5, 7, and 9. So each element is pretty much independent. So that's why our answer is 5. So let's pick up the third case, 1, 2, 5, 6, 5. So initially we don't have element, so we'll choose 1. Now our possible values for this is 2 only. So it is correct. For this element, our possible values are 2 or 3. And 5 does not belong in this range, so we have to choose 5. Now our possible values are 6. So this is correct. And now our possible values for this is 6 and 7. And since 5 again does not belong here, so we need to include this 5 also. So our number of elements comes out to 3. For the fourth test case, it is 1, 2, 4, 5, 3, 7, 8. Right. 1, 2, 4, 5, 3, 7, and 8. Right. So we can choose 1. Now this 2 is correct. Now this 4 is not correct. So we have to choose 4. So our 5 comes out to be correct. And again, our 3 is not correct here. Right. So we select 3. Then our 7 is also incorrect. So we have to select 7. And now we can skip it. Right. So our answer is 4 for this case. And for the last test case, we have 9, 8, 9, 234453. Right. So we'll choose the first element 9. Now we also have to choose the second element. We can skip the third element. And then we have to choose this fourth element too. Now we don't have to choose this 3 or 4. We can skip the next 4 as well because it is between 3 and 5. And now 5 can also be skipped for the same reason. And similarly, we can skip the last element as well because it is between 3 and 6, right? So our answer comes out to 3. So what we can see is that our approach works. Yeah, we can use stack. So let's check the code now. So what we are doing is we are setting min and max the as our L and R, which tells us the range. Initially, I've set my like both the values are as -1 because all my values are positive. So definitely it will be out of range only. And then when my element is out of range, right? Like this if condition tells me if my element is in range or not. So if my element is out of range, then I'm increasing my count, which is telling me the number of elements. And then I'm setting my minimum and maximum to I plus 1. And in case it is in range, then I'm setting my maximum to I plus 1. So this is basically giving me a range for each index and I'm getting the count, right? So this is basically the code for problem C. And now the thing is we can do this same implementation using stack as well. So for this problem, it was not required, but when we move on to the second problem, that is C2, now we will understand why it was actually important. So in C2, what we need to do is we need to compute the sum of values over the entire interval, right? So the algorithm is pretty much the same. So what is different is for a sequence B of an integer, let us define FB as the length of the shortest sequence that could be given as input for the algorithm to generate B. So for C1, we only had to find FB for an entire array. But now we need to find FB for all the segments of A, like from AL to AR, right? So we need to find this sum for all subsegments of A, right? And actually, sum of minimum length, right? So first of all, let's discuss how will we solve the problem C1 using stack because it will help us in C2 and we'll know how it is helping after discussion, right? So let's take this example again. 5 6 7 6 7 8. Right. So now let's approach this problem in a kind of a different way. Now we know that this element is 9. So to remove this element 9, we need an 8 before it, right? So we can see that we have a 8 here, so 9 will uh, be destroyed when it will reach this point, right? Similarly, for removing this 8, we need a 7. And our 7 is available here, right? For 11, we need this 10. For 10, we need this 9. For 9, we need this 8. And for 8, we need this 7, right? Similarly, for 7, we need this 6. Then for 6, we need this 5. For 7, we need this 6. And right. And let's take another example. Let's say we have 5, 6, 7, 6, 8, 9, right? So what I said was for removing this 9, we need a 8. For removing this 8, we need a 7, right? And now for removing this 6, I need this 5. For this 7, I need this 6. And for 6, I need 5, right? So this required one element, right? And according to my logic, this should also require one element. But is that the case? Bro, can you tell about the Codeforces clock extension which you have? So I'm assuming you mean this extension, right? So actually it is CF tracker, but maybe this is now not available on Chrome, I'm not sure. But if you just search CF tracker, right, this is the extension. It is pretty useful because it gives us the time estimate we have given on a specific problem, right? So now actually let's see whether we can get, like, our answer is actually one or not from our previous approach, right? So we know our first element is 5, our next element can be 6, so it is also fine, and our next element can be 7. Now for our next element, it can be anything from 6 to 8, right? So it is 6. And now our this element can be anywhere from 6 to 7, but this is 8, right? So I need to select this element as well, and now this element is 9, so it is fine. So according to my algorithm, my answer should be 2, right? So first of all, what I suggested earlier was not right. But this worked for the previous example, right? So what is the issue now? If you notice the arrows here, like when I required 7, so my entire like my entire segment inside it was already constrained inside, right? Like there was no overlapping arrow here. Like we can see some overlap here, right? So let's actually check this approach in a better way. So what we can do is, let's say we have like we need to find like for an element, like what exactly we need to do. For element x, we need x minus 1 to remove it, right? This is our first point, but there is another condition, right? And this x minus 1 is, like, let's say this is index I and this is index j, so definitely j is less than I, right? And all elements between I and j should also get removed by values or when we reach I. Right. That is what I can say is that x minus 1 element needs to be accessible for x to remove x, right? So let's check our second case first. Our second case was 5, 6, 7, 6, 8, 9, right? So since we are iterating from the back, let's say we first of all have 9, right? Now, then we move to the second element 8, and now we know that we can remove 9, right? Because 8 is nothing but 9 minus 1. So we removed 8, 9. And now we have 8 left, right? Now we move to the previous element that is 6. Now we can't remove 8 from 6, right? So our 6 is left. Now we move to the previous element that is 7. Now again, see, now we can remove 8 by 7, but the thing is we also have 6 before it, right? So first of all, we need to remove this 6 to be able to remove the 8, right? So since now we can't remove 6 with the help of 7, so our 7 will remain here. And now our next element is 6. Now we know that we can remove 7 with the help of 6, so our 7 will be removed and we will get a 6. And now we get 5. So with the help of 5, we can remove the 6. And now since this 6 is removed, then the next 6 which we had earlier will can also be removed, right? But now this 8 cannot be removed because again for 8 we require a 7 and we no longer have a 7. So we are left with 5, right? So that's why we have two elements, right? And let's check the same approach for our previous test case. Does this work? It was 5, 6, 7, 6 to 11 and 8, 9, right? 6, 7, 8, 9, 10, 11 and 8, 9, right? So let's do the same thing. First of all, we have a 9. It will be removed by 8. Now we have 11 and 11 cannot remove it, so 11 will stay. Now our next element is 10 and 10 will remove 11. Then our 9 will remove 10. Our 8 will remove 9. And now our 7 will remove 8 and then this 7 will also remove the 8 we had earlier, right? And now our 7 will be removed by 6. Now our next element is 7. It cannot remove 6. Now 6 will remove 7. And now our 5 will remove both of these 6, right? So we are left with 5. So this is one element. So can we say that our answer is number of elements left? And like, can we guess what was our data structure which we are using for this? Isn't this pretty much stack? Because first of all, we are removing the element we have accessed the latest, right? What is stack? Last in, first out, right? So can't this problem be solved using stack, right? Like someone wrote in the comments also, right? That we are using monotonic stack. So this is basically the monotonic stack implementation. Right, Nikhil mentioned it. So we could solve C1 using the stack approach also. But the thing is, how will this help? Right. In C2, we need to find the length of the entire operation, right? Like for all the subsegments, we need to find our answer. So the thing is that if we could do the same approach for each subsegment, then we could directly get the answer. But the thing is that is definitely TLE, right? So we need to optimize our approach somehow. So actually, let's pick up a smaller example because this example is too long. Or actually, let's do it with this example only, right? Our example is, oh, it's my bad. I'm picking up the stack instead. Actually, let's pick up this example. So basically, what all subsegments we need to solve? It is 5, 5, 6, 5, 6, 7, 5, 6, 7, 8, 5, 6, 7, 8, 9. And similarly, same for 6. And similarly for 7, 6, 8, and 9, right? Now, instead of solving for each example, which is pretty hard, right? Let's modify our approach. What we can do is let's find number of segments each element survives in. Right, let's find this. Isn't this basically the same thing? Right? Aren't these equivalent? Right. Because what exactly is happening here? We are saying that in this case, 8 and 6 survived, right? So 8 and 6 both survived in one of the segment, right? So if we can figure out how many segments each of these elements survive in, won't it be the sum of net length only? What question are we discussing? We are discussing problem C2. We first discussed the stack approach, monotonic stack approach for C1, and we are extending it for C2 now. So I'm saying that the summation of smallest length, that is summation of FA for all subsegments, is equal to summation of GA, right? For all I, that is for all elements, right? And FA is smallest length for a subsegment, and GA is, or I should not write this as GA, right? I should write this as GI, right? Because I'm iterating on I here, right? And why would this be easy? Because for FA, number of subsegments were like n square, right? But now for GI, number of elements, that is n, right? So what we need to do is, if we can solve for each element together, then it will be possible, right? See, if for each element again it will take of n, then it is of n square only. But in case we can solve for each element in one go only, then it will be of n only, right? Because we are solving for n elements only. So that is our main motivation. So now let's go back to our approach for how we were solving with this with stack. So our array was 5, 6, 7, and 6, 8, 9, right? Right. So basically, how many times are each element surviving? I am interested in that, right? So let's say initially I've picked element 9, right? So I know that when I'm moving to my second last element, then 9 is not surviving, right? So basically 9 only survives one subsegment, right? So can I write 1 here? Because after this 9 is destroyed. And then our next element is 8. And now 8 still survives, right? After 6. And then 6 survives 7. And now when we get 6, then our 7 is destroyed, right? So 7 is destroyed right next to 6, right? So how many segments does 7 survive? 7 survives the segments 7, 7, 6, 7, 6, 8, and 7, 6, 8, 9, right? Which is 4 segments. Or before discussing this, let's also discuss one more thing. It will help us in this. Or let me just write it down only. Like Let's say our segment was 5, 6, 7, 6, 8, 9, right? Number of segments for I starting with I. We can directly find this, right? For the last, it will only be 1. For second last, it will be 2, and so on, right? Right. For example, for 7, we just discussed it is 7, 7, 6, 7, 6, 8, and 7, 6, 8, 9, right? So we know for ith index number of segments starting with I is nothing but n minus I plus 1, right? And this is definitely 1 based, right? For the first index, it is 6 minus 1 plus 1, that is 6. For the second, it is 6 minus 2 plus 1, that is 5, and so on, right? So now let's move back to our problem. Right. And now we need to find the G of I, right? Number of elements each segment survives in, right? We already know the number of segments starting for, we have calculated this. So first of all, we have taken 9 and 9 is removed by 8. So it only survives one segment, that is the segment 9, right? Corresponding to this. Now our 8 is not destroyed by 6 and 6 is not destroyed by 7, right? Then our 7 is destroyed by 6, right? So basically 7 survives all the segments in which we have included 7 but we have not included 6, right? So these are basically 4 segments, right? 7, 7, 6, 7, 6, 8, and 7, 6, 8, 9, right? And now this 5 destroys 6, right? So again, for 6, how many segments does it survive in? Isn't it 5? Because in 5 segments we have 6 but we do not have 5, right? Right, these 5 indexes, right? And now this 5 also destroys this 6. So how many index does this survives in? Isn't this nothing but 3 plus 3 plus 3? Now why? Because for 6 we had the segment 6, 7, like 6, 7, and oh sorry. For 6 our segments were 6, 6 and 8, 6, 8, 9. But it also survived 7, 6, 7, 6, 8, 7, 6, 8, 9, and similarly 6, 7, 6, 6, 7, 6, 8, and 6, 7, 6, 8 died, right? But it did survive when we took 5, right? So basically these are 3 for each of them, right? So isn't this just 3 into 3? And This first three is nothing but number of segments starting with I, and this second three is what? Number of elements it survives. Right. Because this six survived itself, then it survived seven, and then it survived six. So it was destroyed by five, right? So this distance is three, right? So now our six is removed and now five is left, right? So actually we haven't calculated answer for each of them, right? So our array was 5, 6, 7, 6, 8, 9, and we have calculated the answer for 1, 4, and 5, right? And we have also calculated the answer for this 6, which is 9. And now in our stack, the elements left are 8 and 5. So basically, these elements are not removed by any of the elements, so these survives, right? And this is basically answer of C1 also, right? So basically, 8 survives itself, it also survives 6, it also survives 7, 6, and 5, right? So it is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. So isn't this just 2 into 5, 10? And similarly for 5, isn't this 6 because it only survived itself, right? There's no element here, right? So our answer is summation of this, right? Which is 6 plus 5 plus 4 plus 35, right? So let's try this approach on one of the test case because for this one we need to calculate it manually and it is very tedious. But what we do know is that for ith element, our answer is like number of segments where L is I, right? Our segment is L to R, right? Times distance from the element it is removed by, right? Isn't this basically our answer? So let's check this on the given on some given test case. Let's check this for the last example because this was the best example, right? We have 9, 8, 9, 2, 3, 4, 4, 5, 3. Right. So let's calculate the first quantity for all of them. That is number of segments where these are the starting index. So it is 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? And now we need to multiply all these values by some value, right? To get the actual value for all of them, right? And first of all, we have taken the 3, then we have taken 5, and then 5 is removed. Now 5 is removed by 1, so it is 5 is removed by 4, right? So it is the distance is 1. So we get 2. Then we put 4, we put another 4. And now this 4 is removed by 3 and the distance is 1. So it is 4. Now for this 4 the distance is 2. So it is 6. Now we put the 3 and this 3 is removed by 2. So again the distance is 1. So it is 5. Now this 3 is removed as well, and what is the distance? 1, 1, 2, 3, 4, 5. Right. This distance is 5 on, right? So 1 times 5 is 5. And now we are putting 2. Now we put a 9 and 9 is removed by 8. So this is times 1, which is 7 only. Then we are putting 8 and we are putting 9. So these values are not removed, right? So for all of these values, the distance will be the number of elements left, that is 1, 2, 3, 4. So 4 for 2, which is 24, 2 for 8, which is 16, and 1 for 9, that is 9, right? So our answer is summation of all these values, which is 9 plus 16 plus, right? So 9 plus 16 is 25, with 7 it is 32, 56, 61, 65, 71, 73, and 78, right? So our answer comes out to be 78. And we can see that's the answer, right? So this approach works, right? So let's discuss the code now. So what we have basically done is we have initially set the answer vector to like this value only, that is 1. Like we have set the vector to this value, right? And then we have created a stack. And now we are, for each element, we are checking if our top element minus 1 is equal to our current element. In that case, we are removing the element from the stack, right? And while we are removing the element from the stack, we are multiplying it by the distance, right? And then we are pushing the current element. Now, this stack dot size is nothing but the answer for C1, right? And now for rest of the element, we are multiplying with the number of elements that were left to the left, right? For each of the element that was not removed. And then we are adding it to the answer. And finally, we are taking the sum of this whole quantity, and that is our answer. So basically, this was our C2. So I hope this question was clear. It was a bit tricky, I would say. Yeah, so let's move on to the last question now. That is D for this discussion. So there are 2n cards with numbers from 1 to n, and each of the number is written twice. Each card has only one number written on its front. You will play a card flipping game. Initially, all 2n cards are placed on their back, the side without number. In each turn, you flip exactly uh, two cards, And if the two cards have the same number, you discard the two cards. Otherwise, you flip them back to their original position. You win when all the two and cards are discarded. Note that you do not have to flip the two cards simultaneously, so you decide on your choice of the second card after seeing the number on the first card. Consider the following greedy algorithm to play the game. Initially, the two cards are placed in a row arbitrarily. Then your strategy on each turn is as follows. If there are two cards that you have flipped previously and have the same number, flip those two. Flip those two cards. Otherwise, flip the first card that you have never flipped so far as the first one. And let's say this card has a number X. Afterwards, if there is another card that you have flipped previously and has the number X, flip that card. Otherwise, flip the first card that you have never flipped so far, including in this turn, as the second one. It can be shown that the algorithm strategy is uniquely determined on every turn. You must solve the following problem regarding the algorithm stated above. Given some n and k, find a possible orientation of 2n cards for which the above algorithm takes exactly k turns to win the game. Additionally, such an orientation does not exist. Please report so. So, what we can say is this is a constructive algorithm question, right? We need to find some way to make a possible orientation so that our game will end in k moves, right? And our n is up to 3, 5, and our k is up to 1e7, right? Sorry, k is up to 1e6. So again, either O of n or O of n log n will work for this problem as well. So let's discuss the possible approach. Right. So let's say we have n, like we are given some n and k, right? And we need to make, right, this is a problem. And right. And what exactly is our algorithm? Let's say we have two cards. Let's say we have two cards X and X. We have seen them. Actually, let's discuss the strategy from some examples, right, instead of this. Okay, so let's consider n equals to 4 for now. Or let's take n equals to 5 instead. Or let's solve for small n's, right? Let's start with n equals to 1, right? So what is the possible, like only one orientation is possible. And we can end this game in one move, right? Because the moment we will select the two cards, they will be removed. Now for n equals to 2, we have four possible combinations, right? Actually, not four. There are six, right? Right. And for this, first we will select the first card and then the second card, and both of them will be removed. And then the same will happen for the other two. So this is two moves. For this, we'll select the first two cards. They won't be removed. Then we'll select the third card, and then the first card, then the fourth and the second card. So it is three moves. It is the same for this as well. And similarly for this, and again the same for this example as well. And now the last example follows the first case, right? So now for n equals to 3, how many cases we'll have? We'll have 6 factorial by, right? So definitely we are not solving all the 90 cases. So we need to find some pattern. Right. So, right. So let's discuss what are the, like, let's discuss the ranges of K, right? Right. So first of all, we can definitely choose numbers like this, right? And in this way, we can see that each move removes two numbers. So, so basically, K is right, and this is right. Can we say one more thing? That is, we always require n moves for removing elements, right? Right. And why is this so? Because since we have two n elements and basically we need to remove all the elements. So, and in one operation we always remove two elements. So n moves are definitely required for removing the elements. So can we say that our k is equal to n plus number of moves where no element is removed, right? Isn't this basically a number of moves? Right. And we know that the minimum value for this is, but we don't know the maximum value. Right. Now, what are the possible ways when we actually remove the elements, right? There are three statements here, right? That is, if we already know two elements that are same, we remove them. Else, let's say we flip a number and we have already seen this number, then we remove them. Or let's say when we flip the second number, it comes out to be equal to the first number, then we remove them. So, what is the best approach? What is the best of them? Best is when second random is equal to first random, right? And what exactly is worse? Worst. Second random is some previously known element. Right. Now, why is this first? Because when we have seen the second element, then we aren't able to remove the element in this case, right? We are removing the element in the next case. And actually, isn't the other approach also best? Actually, let's not analyze them this way, and let's analyze them again. Like this is not a good way of analyzing, right? So we have three possible operations, right? Our first operation is second random is equal to first random, or first random already seen, or what can happen second random already seen. Or what can happen second random is not unseen. Or I can write this as or we can write one more possible way. Right. So what I can say is that when we know two equal elements, so we will remove them. So so this is removing two elements, right? And in this one, second random and first random are equal, right? So here also removal is occurring, right? And here our first random is already seen. So here also we are having a removal, right? In the third one, we are moving to fifth operation, right? Because now we know two randoms we have already seen, right? Isn't this neutral? Because this is only increasing our number of possible different values, right? It is not really doing anything. So out of these five possible operations that can occur in each move, three of them are removing an element, right? And can we say that the first one is best because it directly removes two element, and we have already seen that this was coming out to be minimum when all our operations were actually the first operation. Can we say that independently this is also good, or we can say best only? Because this way we are removing we are removing two elements in this operations, and actually let's just do one more thing here, right? Let's check how many elements processed after this, right? Because once we process all, they will be removed, right? Right, basically we need to process all elements, right? So in the first one, let's say we have processed I elements. Like so far we have processed I elements, right? So what happens in the first one? We are processing the I plus 1th and I plus 2th element and removing both the elements. So process element reach I plus 2, right? What about the second one? So can we say that's why this is the best? The first random is already seen and that's why we are removing it. So our processed element reach I plus 1 and it is still good. In the third one, the second random is already seen. So our process reached I plus 2, but next operation doesn't increase this. Bad, right? More operations. Right. What about our fourth one? Both elements are unseen. So I plus 2 processed, no removal. will cost operation in future. Right. We need to come back to remove these elements. Right. Not very good. Right. And what about the fifth one? I processed but removes two elements. Necessary step, right? So can we say that if all our operations are operation one only, then it's best. That's why we were getting n operations when all of them were the first operations. And in case of the second operation also, isn't it's not that bad, right? Because it is causing us some more operations, but elements are getting removed, right? Now in the third one, it's causing us operation number 5, which is not removing any element. So isn't this bad? So can we say that our worst, like this will generate k max, and this is just increasing the number of elements we have seen, right? So this is will also play a role. Like let's take some examples. So we know that if we are have one, two, two, three, and so on up to nn. So this is all operation one only. Like this is basically operation one, right? Why is this lagging so much? Right, and this takes n operations, right? What about one, two, and then we again see a one to remove it, right? And then we see another new element three, then we remove two, then we see another new element four. Or actually, the thing is that it will also cause operation, but we are only interested in the best and the worst part, right? So this is the best one where it is causing us n operations. So this is best. And what is the worst? When our second element is always seen, right? Right. Our second random is already seen. Now, how to cause this? Right. Actually, I think it is causing issue when I'm right, minimizing it. So, right. So, anyways. So let's say I have one, then I have two. Right. So I've seen these two elements now, right? Let's say my next element is three, and then I'm getting four. Sorry, then I'm getting one. So now my next operation will be choosing of ones, right? Now let's say my next value is 4 and then I'm getting a 2. So now it will remove 2. Now my next value is 5, then I am removing 3. Then it's 6 and removing 4. And so on it is up to n and n minus 1. And then what we can say is suppose you have done this up to 6. Right. So sorry, this is n minus 2. So my elements n and n minus 2 are n minus 2 is removed, right? So n minus 1 and n are left, right? So n minus 1 and n, right? So how many operations will it take? 1 and 2 is one operation. This is second operation. Now 1 is removed. This is third. So can we say all of these are basically two operations? Like 3, 1 and then 1 is removed, 4, 2, then 2 is removed. And how many elements are these? I am choosing all values from 3 up to n, right? So this is 2 times n minus 2. This is one operation. And choosing n minus 1 is one operation, and choosing n is also one operation, right? So this is 2 times n minus 2 plus 3, right? Which is 2n minus 1, right? So, or I can say this is n plus n minus 1, right? So k min is n and k max is n plus n minus 1, right? These are like we have written it here, right? Number of moves where no element is removed. So maximum moves, right, of no removal, right? So first of all, what we can say is that if k is less than n or k is greater than 2n minus 1, then it is not possible, right? And what was the case of not possible? So we need to output yes or no and then the sequence, right? So the answer is no. Else it is yes, right? Now let's say we have n, right? Let's say we choose k elements for worst operation and rest of the n minus k element for best operation, right? So how many operations we will have? We will have 2k minus 1 plus n minus k operations, right? Or basically we will have n plus k minus 1 operations, right? And what can be the possible values of k? This k can go from, actually let's not choose k. Let's choose k1 for example. K1 can go from 1 up to n, right? And so our number of operations can take any value from n plus 1 up to 2n minus 1, right? And this is our best case, this is our worst case, right? So we already know n and k, right? So what we are basically doing, if k is less than n or k is greater than 2n minus 1, then it is no, else it is yes. And for this second case, what we can do is now basically what is k1? K1 is equal to, right? We need to find k1, right? And we know that n plus k1 minus 1 is nothing but k, right? So basically k1 is nothing but k minus n minus 1, right? Or let's not make this n minus 1. K1 is nothing but k minus n plus 1. And then all we need to do is first k elements, worst, next n minus k elements, best. And we already know what is worst and best, right? Best is 1, 1, 2, 2, 3, 3, and so on. Worst is 1, 2, 3, 1, 4, 2, 5, 3, and so on up to n minus 1, n minus 2. And then this is n minus 1 and n, right? So isn't basically this our problem? So let's check the examples. For example, this is 2 and 3. So here, what is K1? K1 comes out to be 1, right? So we have 2 and 3, right? Actually, what is K1 here? K1 is 3 minus 2, that is 1 plus 1, 2, right? And how will we, can we also see one thing? Okay, this is lagging again. Like, what do we require for this? Like, let's say our n is 3. In that case, we get 1, 2, 3, 1, 2, 3. This is good. For n equals to 2, what do we get? 1, 2, nothing here, and 1, 2 again. So this is also fine, this is also fine. Why? But for n equals to 1, I mean, for 1, there is only one possible way, right? 1, 1. So there is no best or worse here, right? So for example, we have 2 and 3, right? Here, our k1 comes out to be 3 minus 2 is 1 plus 1 is 2, right? So what we do is we generate a sequence of 1, 2, 1, 2, and then it is followed by 3, 3. So this is one operation, this is two operation, this is three operation, and oh, sorry, there are only two elements, right? So these are basically three operations, right? For the second case, we have 3 and 4. So again, k1 comes out to be 2. 4 minus 3 is 1 plus 1 is 2. So 1, 2, 1, 2, followed by 3, 3. So this is one operation, two operation, three operation, and this is fourth operation. So it is correct. For the next case, we have 3 and 2. So k cannot be less than n, right? So this is false. For the next case, we have 3 and 5. Right. So k1 comes out to be 3. So it is basically 1, 2, 3, 1, 2, 3, right? First operation, second operation, third operation is 1, fourth operation and fifth operation, right? Now for 6 and 67, the last case. Again, the maximum value is 6 into 2, 12 minus 1, 11. So 67 is not possible. Let's do the case for 6 and 10. Right. So K1 comes out to be 10 minus 6 is 4 plus 1 is 5. So my elements are 1, 2, 3, 1, 4, 2, 5, 3, and followed by 4, 5. And now my last element that is left is 6 and 6, right? So one operation, two operation, third operation, fourth operation, fifth operation, sixth operation, seventh operation, eighth, ninth, and finally the 10th operation, right? So we can say see that our approach works. So let's check the code now. So yeah, our code is basically that what we are doing is we are subtracting n from k. So if k becomes negative or k is still greater than equal to n, then it is not possible, right? Because we already checked that k should be less than n, right? So we can write this as k minus n less than 0 or k minus n greater than equal to n, right? And then I'm increasing k by 1. So basically this is my k1, right? And now if this value is greater than 1, then I'm like doing that operation only. The first two elements are 1 and 2. The last, right? The first two elements are 1 and 2. The last two elements are k minus 1 and k. And then I'm doing I minus 2 in between. And then finally for the rest of the elements, I am just printing I and I, which is the best operation. And in case k is 1, then I'm just printing I and I for all the values, right? So this is basically the solution for this problem. And that's it for this contest. We have discussed up to problem number D. So I will be ending the stream now.